So, friends, good morning and welcome to this lecture series of geomorphology. Today, we will continue with this coastal geomorphology, and if you remember our last class, we are talking something about this wave tank experiment, the coral reefs and some of these structures or the rock structures, how they influence the coastal geomorphology. And we concluded that the breaking waves and the broken waves both are more sensitive or more effective for the coastal erosion. And in initial time there will be less erosion. However, after few moments or few hours, I am talking about this wave tank experiment. After few hours, the erosion will increase because much of the sand particle will be eroded from these coastal cliffs. So, the water along with the sand particles, they behave as an abrasing agent to erode the coast rapidly. And at the later time, when much sediment will be added to the system, the energy will be absorbed and finally, the rate of erosion again it will decrease. Similarly, this eroded material will be transported seaward and will form a convex up topography along this coastal plain, and finally, this is the depositional topography, it will be convex up and it will be within the submerged water. Similarly, when we are talking about these coral reefs, we found these are the reefs, organic built reefs, and they are formed on the hard rock surface, and if hard rock surface is not there and the coral reefs are formed, the coral reef itself behave as a substrate to allow the growth of this coral reef further. And there is a leeward side, the steep side mostly attached to this rock body, and it is the most resistant wave resistant formats, wave resistant species, they are found along this seaward side. And on this flat surface algal mats are developed, and those algal mats, the algal limestones, they behave as a binding material to make this coral reef more strong. And until unless there is a severe storm activities, tsunami activities, the coral reefs are not destroyed or disturbed and it will remain there. So, today we are going to discuss about the classification of coral reef and how this classification will be helpful to study this tectonics and climatic influence along these coastal plains. So, this classification is quite old and it is given by Darwin 1837, but still we are adopting this classification. This classification, the main aim to categorize the coral reef into different classes, and based on those classes we can predict about this coastal subsidence, tectonics and climate, sea level rise, something else. So, here the basic coral reef classification was given by Darwin in the three main type: the fringing reef, the barrier reef and the atolls. The fringing reef, if you see these figures given below, here suppose we have a volcano and with time we are creating a volcanic island. And as we know, these coral reefs, they are very sensitive to temperature of water. They are basically the warm water species, and if it is cold water should not be less than 18 degrees Celsius. So, if you see, if we have an island, a volcanic island, that means this region around this volcanic island will be hot and warm water will be there. So, due to this warm water condition, you see there is growth of corals in both sides. So, you are looking at the cross section, it is not both sides, it is all round this volcanic island. If you see here, this is volcanic island, the green one, and these corals, they are growing here. So, that means all side or the periphery of this island. So, this coral try to grow, and this is a shallow water phenomena, because we know these coral reefs we need a photic zone for the coral growth. So, if you see, it is not extending much deeper of this island. So, however, it is restricted here, this side is restricted here, and around this volcanic island at the shallow water level the coral try to grow. So, once they started growing and gradually they increase their height. Now, you see, earlier this was the depth or the height of this coral, now this is the height of this coral. So, with increasing height, part of this main sea is cut off from this main water body, and now it is restricted here. If you see, it is a restricted environment and forming a lagoon. So, this is called barrier reef. Barrier, that means it is a barrier from mainland to this main sea, and a part of this water body, main water body, it is cut off from this main water. So, this is forms a barrier. So, now these corals they behave as a barrier. So, that is called barrier reef. Similarly, the third one, it is called atoll. Atoll means, if you see in this condition, we do not have this volcano or volcanic island existing. Here existence of volcanic island there, existence of volcanic island is there, but here there is no volcanic island. So, now the question is how this volcanic island vanished in between. You see, there are two reasons. One is, once it is a tectonic active environment, there are much chance that this volcano island will subside, or there is a chance the sea level increased or the water level increased and the volcanic system totally submerged under sea. So, either of this case, if you see, this total system is submerged, there is no surface signature of this volcanic island, and these corals they are existing here, and it had totally engulfed a lagoon here. So, this is called atoll. So, these three principal classification, one is fringing reef, another is barrier reef, and third is atoll. So, this atoll that indicates either there is a tectonic subsidence or there is a sea level rise. So, Darwin 1837 conceived these three reef forms as a genetic sequence by which fringing reef around a submerging central island would progressively become barrier reef and then atoll. So, this is a progressive increase with time. It starts with fringing reef or it starts with volcanic island, then there will be development of fringing reef, then development of barrier reef, then development of atoll. So, it is a sequential format. So, continuing with this classification, we see this classify the organic descriptive scheme of classification of the organic reefs. One is, it is forming island without central lagoon and with central lagoon. So, this is two divisions, one having central lagoon and without having central lagoon. If we have a central lagoon inside, either it is a deep lagoon or it is a shallow lagoon. Similarly, here if it is deep lagoon or shallow lagoon, or if it is a shallow lagoon, either it is a large lagoon or small lagoon. Similarly, without central lagoon, either it is a large reef or a small reef or a very small reef. Similarly, here it is fringing reef, barrier reef, platform reef, platform means flat topped, then patch reef means it is not continuous, it is patchy, then coral pinnacles, then oceanic atolls, then shelf atolls, then furrows. So, these pinnacles, if you remember our last class when we were talking something about this flat topped body of a flat top sediment, or it is horizontal sediment like these sedimentary rocks, then they form the sea bridge and finally, this collapse and forms the pinnacles, this chimney like structures. Similarly, in the coral system, they also chimney like structures are there, that is called pinnacles. So, coral reefs are very strictly controlled by sea level datum. Emergence or submergence or even few meters completely displace all the depositional and erosional zones of the reefs and creates a relict form, because they are very sensitive to water level, they are very sensitive to climate change, they are very sensitive to EH-pH condition or this chemistry of water, the temperature of the water. You might have heard even nowadays the Great Barrier Reef of Australia, it is getting destroyed due to this water chemistry. The severe pollution is there in this ocean, so that the water chemistry is getting changed. So, that is why these corals nowadays they are not growing at that rate which was earlier. Similarly, some part of this barrier reef are getting destroyed and not new coral reefs are getting formed nowadays. So, they are very sensitive to temperature, water chemistry, water depth. So, either a meter of rise or meter of fall of sea water, that will change the characteristics of the coral reef. Okay. So, either they will erode or they will be form new one. Quaternary sea level fluctuations have laid a particular complex record of coral reef. When sea level was low, that reef surface was exposed. So, once you see coral reef, as you know, that is totally limestone. So, limestone exposed to the surface, that means it will promote for the formation of karst topography. Karst topography, when we are talking something about weathering, these limestones they are very sensitive to chemical weathering. So, that means once the sea level falls during this glacial period, when most of this water was in the glacier form, the sea level was below 100 meter or so compared to the present level. So, in that level if coral reef was there, that means 100 meters surface was exposed. So, 100 meter depth surface is exposed, that means it was interacting to the atmosphere, interacting with the rains and some other types of material. So, that means there was karst solutions, there are karst topography were developed, and now you increase the sea level. Now, in the late quaternary the sea level has increased, and due to increase of the sea level, this eroded topography or the eroded karst topography developed on the coral surface, they were again submerged and again the coral reef started forming. So, that means we have the evidences of past karst solution topography on the coral surface. So, that means when the sea level was low, reef were exposed as flat topped or hill rimmed islands that were subject to karst solution and peripheral wave erosion or reef growth. So, here drowned karst topography is well shown in the floor of some of the reef and lagoons. So, that means the sea level increase and decrease that are affecting this karst topography or the coral topography. So, how we can detect whether a part of this coral reef were eroded or it is intact as it is. So, because we know this unconformity, if you suppose one surface is exposed and it is eroded, so another sediment is deposited, we are creating an unconformity. Similarly, there was inconformity or there is unconformity within the coral reef surface also, because during this sea level fall, the part of this coral system was destroyed, eroded, and later due to the sea level rise, this part surface is exposed and it is again promoted coral reef growth. And so, this eroded part, because eroded part it is difficult to identify, because below is this limestone and above is the limestone, both are this organic limestones. So, they can be modified by the organisms. So, it is difficult to identify exactly where this erosional surface lies. Development of this sophisticated radiometric dating techniques become unavailable. There was no way to evaluate or often even to detect the glacial age disconformities within this coral reef stratigraphy. So, because this total system is organically modified. So, this organically modified, that means we cannot distinguish whether there is an unconformity existing or not. So, that is why by centimeter by centimeter, millimeter by millimeter, if we do not analyze it with the stratigraphic column total coral leaf columns, we have to date it centimeter by centimeter scale, then we can found where is the age gap. So, those age gaps that determines when this glacial activities was there, this the glaciation was there, so that the coral leaf was exposed to the surface. So, on a longer time scale, the Great Barrier Reef of Eastern Australia, which extend almost about 2000 kilometer from 9 degree to 24 degree south latitude, began to grow in the northern part, becomes between 16 to 25 million years, and in the central part 10 to 15 million years, and the southern part only a few million years ago. So, why it happening so? We have a 2000 kilometer long stretch coral reef, and the northern part it is showing older, that means it is 16 to 25 million years, and the middle part it is 10 to 15 million years. So, gradually we are moving towards northern part, the age of this coral reef is decreasing. So, that means how it is possible, a straight coral reef like this side is older, this is middle aged, and this is younger one. So, this indicates the tectonics process, this indicates the plate movement. If you see here, this Australian plate it is moving northeast direction, and here is the reef system, Great Barrier Reef system suppose. So, now you see once this is coming to warm water climate, so it developed coral reef here. So, similarly with time, suppose it is 25 to 16 million years, within time it started with 25 million years and it is 16 million years. So, with time again this part moved further northward northeastward. So, due to further movement the coral reef started forming here, then further northeastward movement the coral reef started forming here. So, that means the age anomalies related to northward movement of this Indo-Australian lithospheric plate, as northeastern Australia moved progressively into the tropics throughout this late Cenozoic era. So, that means more and more space it is coming under these tropics, these coral reefs are getting developed. So, that is why there is a great age anomaly from the northern to southern part. Then we were talking so far about these carbonate coasts, something about these structures, these erosions, and these coral reefs. Now, we will discuss about the sandy shores, sand. So, that means those eroded materials which are eroded from this coast, the cliffs, now they are deposited and distributed and redistributed along these coasts. So, how they are creating the landforms, that we will discuss here. So, sandy shores, that is called beach, beach is full of sand. Some of this coast is sandy coast, some of this coast they are rocky coast, gravelly coast. So, that is depending upon this material available, we can classify this coast into sandy, gravelly, rocky, like that. So, if some wave energy were not absorbed in the work of moving sediments along the coast, far more erosional work would be accomplished. So, the sediments in motion along the shore is the beach. So, beach, that means this is the region, it is near to this coast to few meters or few beyond this ocean water or sea water. So, that is coast, because the sediments are under constant motion, to and fro motion, lateral motion, vertical motion. So, sediments under motion, the region is identified as beach. Its role is analogous to floodplain alluvium in the river valley. It absorbs energy and moves during storms, and thereby stabilize the rate of wave energy conservation into geomorphic work. We have floodplains, we know within that floodplains this sand migrate, the sediments transported. So, that means this river energy is redistributed among the sediments get deposited, they transported, and during this transportation they erode materials, again they dissipate the energy within that sediments. So, that means similarly along this coast, the similar type of work this water and the sand together they do, they remove the material, they transport it, they deposit it somewhere, again they rework and redistribute like that. So, it is similar to this floodplain geology and geomorphology. However, here ocean is associated and in floodplain the river is associated. So, beach can be continuous or can be discontinuous. So, the discontinuous, that means when we are talking about these geomorphic models in our earlier classes, you can remember that the coast may be dissected at different places by these rivers. So, a coast can be continuous for hundreds of kilometers or it may be dissected into few kilometers or so, especially in the deltaic regions. Deltaic regions when the river is bifurcated into distributaries, this coast is desegmented. So, the sand sheet is segmented. So, a continuous beach along a coast is a criterion for graded condition as it is a continuous floodplain on the floor of a river valley or a continuous sheet of sediments on a semi-arid piedmont. So, here three dissimilar environment with similar geomorphic events have been described. So, a continuous coast, a continuous floodplain, a continuous sheet of sediments in pediment. So, that means it is indicates the stability. If this continuous coast is there, that means geomorphologically it is stable. Floodplain, continuous floodplain is there without any dissection. So, it is geomorphologically stable. Continuous sheet of sediment on a pediment, that means it is geomorphologically relatively stable. So, this continuity that indicates the stability of a geomorphic system. The post glacial rise of sea level has submerged a variety of sediments including the glacial drift, sand dunes and older marine deposits and alluvium. On a swelling bottom, sand sized are the first to steer up by waves, but as the sand is moved by saltation, it stays within this zone of wave action. Here it is important to understand. We have wave action along these coasts, and wave action, some wave have certain energy. We know from this earlier classes that we need less energy to pick up sand. We need more energy to pick a clay particle and a gravel particle from this bottom of this sediment. So, with a minimum energy we can pick up sands from this bottom within the sediments. So, once the sand comes to this water, so it remains there until unless this wave action becomes calm and quiet. So, it in the saltation process it moves. So, once it moves, it interacts with the other one with the other sand particles, it interacts with these cliffs, it interacts with the other materials. So, it erodes. So, there is a line or there is a point in a profile that is called null line or null point. So, if you see here, this is the profile, you are moving from this continentward to seaward, and within this profile there is a point that is called null point, and in a line it is a line, it is not a point. So, in a cross section it is a point, and if you are looking at the surface from the aerial view, it will be a line that is called null line and it is called null point. So, what is that? A null line or a null point on a bottom profile can be defined seaward of which sand is either not moved or moved seaward. Landward of this null line, there is a net showering movement of the sand by wave action. So, that means so this is a point that defines either sand will move or not move. So, sand will move towards the coastline or sand will not move towards the sea. So, that is called null line. So, null line is based on the sand distribution. So, if you are moving along this or across this coast, that means from continentward to seaward. So, if you are moving there, you will find a particular zone will be there, particular line will be there. So, in this particular line, you will not find sand towards the sea, but all sands are here towards the coastline. So, that is called this null line or the null point. So, each profile have different position of these null points. So, if we are joining those points with the successive profiles, then we can find this null line. So, that means that indicates here this null line indicates this is the position whether either sand will move towards the coast or sand will not move towards the sea. So, that is called null line. So, that means that indicates indirectly the wave action, to what extent the sand can be in the saltation mode within this water, the vibrance of these waves. So, there are certain salient features given here. The rate of landward sand movement is a function of grain size and wave energy. The landward movement of sand is a function of grain size. Grain size, larger grains will not move, and similarly the wave energy, how much energy of this wave is there. High energy waves, they can move even if larger particles towards the coast. Then near shore sand becomes very well settled as it moved shoreward, permitting the sandy bottom to respond to small changes in wave energy. Aeolian energy, you can remember when we are talking about the aeolian system, this saltation it subtracts or it creates a sorting difference, larger particles one side, this smaller particles another side. Similarly, this near shore sand becomes very well sorted. Well sorted means equal grain size or near equal grain size. It is moved shoreward. Gravel beaches are also common, but move only a much higher energy level, because we need higher energy to pick up a gravel. Similarly, we need higher energy to pick up a clay particle. So, that is why most of our beaches, most of the world beaches, they are sandy rather than gravelly, because we need high energy. That is occasionally occurs during flooding, during tsunamis, during storms. We get occasional high energy which is required for picking a gravel and redistributing from one place to another. But this normal energy distribution along this world coast, it is suitable for sand movement and sand redistribution. So, that is why most of this coast in world you will find it is sandy rather than gravelly. Although the null line and the beginning of this net onshore sand transport are well seaward of this breaker zone, breakers cause the most dramatic sediment transport. Here you have to understand this point. Where the null line stands or this null point stands in the profile. For example, if you see here, this is the profile we are coming from this continent towards the sea, and this is the breaker zone. Here this is the breaker zone, the wave breaks here. So, the null point is somewhere here below this breaker zone. So, now if we have null point beyond this breaker zone, so we should have most of the sand here only rather than here, but it never happens. So, why it never happens? If you see, once there is a breaker zone, the energy of this wave is breaking into different smaller waves. So, here it is a high heat area, that means it hits the most, the wave energy it dissipates most here. So, once this wave energy dissipates, this heats it is creates a shearing moment on the sand particles or this bottom. So, this is a high shear stress, this sand comes in a saltation mode within that water. So, once the sand comes in the saltation mode, it will move here and finally, sand is thrown into suspension by each breaking wave. Here the wave breaks down and this system, that means this once the sand comes in the saltation or the suspension mode, that is, and before it can settle to bottom again, it can be moved many meters shoreward and laterally by turbulent currents. So, that is why though we have a null point here, but around this there will be distribution of sand. This is due to the high energy waves, and this is the breaker zone. Once it comes to saltation mode, that will move here and there. So, this defines this sand movement, how the sand will be distributed in those zones. So, I think we will stop here and we will meet in the next class. Thank you.